Hello all, welcome to Sri Guru Edu. In my last video, I discussed the classification of data structure, right? So there are two types of classification. One is primitive data structure and one is called as a non-primitive data structure. Actually, what do you mean by non-primitive data structure? Let me brief out. Non-primitive data structure, which means the data structure which are not directly operated by machine level instructions and also which are not manipulated directly by machine level instructions, which are called as non-primitive data structures, right? So as we know already, there are two classifications. One is linear data structure and one more is called as non-linear data structure. I already discussed linear data structure. So it is nothing but linear data structure is one in which the elements are stored continuously in the memory or sequential in order, that is nothing but one after the another. Example for this is array, stacks, queues and linked list. In these array, stack, queue and linked list, the array elements are stored continuously one after the another. In today's session, let us discuss about a non-linear data structure. Linear, that is nothing but the data elements are arranged one next to one after the another. Then non-linear means the data structure which is non-linear, means which are not arranged continuously. See, in linear data structure, the elements are arranged one after the another. See here, in these we are going to store the elements, but in non-linear data structure, the elements are not arranged continuously or sequentially. And also I can say which doesn't establishes the relationship that is called as adjacency relationship, that is called as non-linear data structure. The non-linear data structure elements are stored non-sequential type. There is no adjacent relationship among the elements. This also we can say that. So here is an example. One is called as tree and one is called as graph. See here, even in tree and graph also the elements are stored, data are stored, but it is not continuously. It is not stored in sequential order. Look here, this is tree. See, here is one element, that is A, there is one more element B, there is one more element C, another element is D, one more element is E, one more element is F, one more element is G. See, in a sequential order, we used to store like A, B, C, D, E, F, G, like this. The elements are stored continuously in linear data structure, either in array or in stack or in queue or in linked list. The elements are stored continuously like this. But here in tree, the same elements, the same data elements are arranged in this pattern. These are called as levels, we used to say. The first level, second level, third level, we used to say. In tree data structure, which follows the hierarchical relationship, it means what? We call it as A is called the root, B and C are the siblings of A, D and E are the siblings of B, F and G are the siblings of C, we used to say. So it means what? D and E hierarchically followed, it's followed by B and B is followed with A, F and G followed by C and C is followed by A, we used to say that. So this is nothing but hierarchical, a hierarchical relationship. This is called as a hierarchical relationship. And also one more example, it is called as graph. You observe here, elements I wrote, you observe. So even here also I took an example 1, 2, 3, 4, 5. How we used to store it in array? Sequentially, right? Say like this 1, 2, 3, 4, 5. We used to store in this pattern. In graph, even elements are stored 1, 2, 3, 4, 5 in this pattern, means which is not stored sequentially, then which exhibits a relationship of pair of elements, which exhibits the relationship of pair of elements, means 1 belongs to 2, 1 from 1 which tends to 2 and from which tends to 5. It means 1 is paired with the 2 and 1 is paired with 5. And in the same way 2 is paired with the 3 and 2 is paired with 4. In this way, in graph, relationship exits between the pair of elements. It is not following the hierarchical nature. Tree follows the hierarchical nature. Graph exists the relation between pair of elements like this. So that in tree and even in graph we cannot arrange the data elements continuously, means the data elements are arranged randomly. That is why we used to call tree and graph or non-linear data structure. I hope this video is helpful. Please share to your friends, let them be benefited, and subscribe to my channel. Thank you.